Imagine yourself standing deep in the Siberian wilderness, where the all-time mountains rise like an ancient fortress against the sky, their slopes cloaked in endless pine forests, and the air so sharp and cold that it cuts into your lungs with every breath. This is no place for comfort, no land where cities or villages thrive, but a rugged corner of the earth where time itself seems to have frozen. Tucked into the cliffs of these mountains is a dark opening, unassuming, easy to overlook if you did not know what you were searching for. Denisova Cave. At first glance, it seems like countless other caves scattered across Siberia, just a dark mouth in a limestone cliff, a place where a bear might have slept through the winter, or where snow leopards might have sought refuge from storms. But behind that darkness lay secrets that would shake our entire understanding of human history. In 2012, archaeologists from the Institute of Archaeology and Ethnography in Novosibirsk, working alongside geneticists from the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, dug carefully into the cold, damp sediments of Denisova Cave. They expected bones of animals, fragments of stone tools, maybe teeth of cave bears or reindeer, ordinary finds for a Paleolithic site. Instead, one day, among the loose earth, they found something that seemed trivial, almost worthless, a tiny fragment of bone, pale, fragile, smaller than a marble, so unimpressive that it could have been overlooked entirely. Most field archaeologists, used to recovering more complete fossils, would have dismissed it as useless, too broken and worn to identify. Yet the scientists here were no ordinary diggers, and they were working in an era when genetic technology had begun to revolutionize the way we think about the past. That tiny fragment was set aside, carefully labeled, and shipped to Leipzig. In earlier decades, it would have been cataloged and forgotten, gathering dust in a museum drawer. But by 2012, Svante Pääbo and his team at Max Planck had already proven in works like Neanderthal Man, In Search of Lost Genomes in 2014, that revolutionary techniques could extract and sequence DNA even from the most degraded ancient remains. Suddenly, a piece of bone no bigger than your fingertip became a potential time machine, a key to unlocking stories tens of thousands of years old. Picture the scene in the lab, the fragment ground to powder, the genetic material painstakingly separated from modern contaminants, each fragile strand of DNA teased out under sterile conditions and then fed into sequencing machines that could read the letters of life like an ancient scroll. In the field, it was nothing more than a scrap of bone, but under the microscope, it transformed into a gateway into a world long lost. And what lay waiting inside this fragment was not just another piece of data, not just another fossil to add to the list, but a revelation that would ripple across the entire field of human origins. If an entire skeleton can tell us how tall someone was, or a skull can reveal the shape of a face, how much more powerful is it when a mere splinter of bone, barely the size of a thumbnail, whispers secrets no eye has ever seen? And isn't it extraordinary to wonder how many other tiny, overlooked fragments in museums and dig sites might hold truths capable of rewriting the human story all over again?
When the results of the genetic analysis finally came in, the fragment that had once seemed insignificant revealed something astonishing. The DNA extracted from this sliver of bone did not belong to an ordinary human, nor did it align perfectly with any of the species already known from the fossil record. Instead, it carried two distinct signatures, woven together in a way that no one had expected. The individual turned out to be a young girl, only about 13 years old when she died, who had lived roughly 90,000 years ago in this remote corner of Siberia. Her mother, the sequencing revealed, was a Neanderthal, a species of ancient humans long recognized for their robust bodies, large brow ridges, and their dominance of Europe and parts of Western Asia. Her father, however, was something else entirely, a Denisovan, a mysterious human lineage that had only been discovered a few years earlier from fragments of bone and teeth also found in the same cave. What the Max Planck researchers had uncovered was the first direct evidence of a child born from two different archaic species of humans. This discovery was not a vague hint, not an inference drawn from patterns in our DNA, but the literal genome of a first-generation hybrid, proof carved into the deepest code of life itself. In 2018, Vivian Sloan and her colleagues published their findings in the journal Nature under the title The Genome of the Offspring of a Neanderthal Mother and a Denisovan Father. The paper sent shockwaves through anthropology and genetics. Until then, scientists had suspected that interbreeding between archaic humans had occurred, based on small percentages of Neanderthal and Denisovan DNA that still linger in modern populations today. But suspicions are one thing, and hard proof is another. Here, in a fragment no bigger than a coin, was the undeniable story of a young girl who embodied the meeting of two vanished worlds. Imagine the reaction in that Leipzig laboratory when the data first appeared on the screens. The sharp intake of breath, the realization dawning that this was not merely another Neanderthal or Denisovan fossil, but a bridge between them. A flesh and blood reminder that these groups were not as isolated as we once thought. From this point onward, Denisova Cave was no longer just a place where prehistoric tools and animal bones lay buried in the sediment. It became a stage upon which the intimate drama of human evolution had played out, a place where populations met, interacted, and left behind descendants whose genetic legacies still echo in us today. That the story of such a remarkable individual could emerge from a bone fragment once deemed unimportant forces us to reconsider what else we might be missing. How many other overlooked scraps, lying forgotten in boxes in museum basements or still hidden beneath the soil, might contain equally world-shattering secrets? And if the story of one young girl named Denny, as the researchers came to call her, could reveal so much about our shared past, then what does it say about the countless other lives that came and went in silence, their stories yet untold, waiting for us to listen?
Inside the sterile white walls of the Max Planck Institute for Evolutionary Anthropology in Leipzig, the fragment from Denisova Cave underwent one of the most delicate processes in modern science. Technicians in full-body suits handled the bone powder with extreme caution, ensuring not a single speck of modern human DNA contaminated the ancient sample. They knew that one careless breath, one stray hair, could corrupt thousands of years of history. But as the sequences began to appear on their computer screens, what they saw was unlike anything before. The genetic signature carried elements that unmistakably belonged to Neanderthals. The same mitochondrial markers, the same unique traits that Svante Pääbo had spent years decoding when he published Neanderthal Man: In Search of Lost Genomes in 2014. But alongside those Neanderthal traits, there was something different, something that matched the patterns of the Denisovan genome, a lineage first revealed only a decade earlier through scraps of DNA extracted from a finger bone in the very same cave. For years, the Denisovans had been a shadowy presence, known more through genetics than through bones or artifacts. To suddenly see their genetic imprint directly combined with that of a Neanderthal in the genome of a single child was nothing short of shocking. The researchers repeated their tests again and again, suspecting contamination, error, or machine malfunction. But every result told the same story. This was no accident. Here was the genome of a girl who was half Neanderthal and half Denisovan, a living bridge between two vanished worlds.
The discovery did more than prove that interbreeding had occurred. It demonstrated that it was close enough, common enough, that at least one such child lived and died, leaving behind a bone fragment in the dust of Denisova cave. This was not a rare fluke, but evidence of intimate, direct contact between populations we once thought of as separate branches of the human tree. And if these branches intertwined here, in the heart of Siberia, how many other times and places might they have crossed paths, leaving echoes in the genetic record?
The implications of this revelation rippled outward, challenging not just scientific models, but our very imagination of prehistory. Denisovans had been ghosts until then. Almost no fossils, barely any physical presence, and yet they left a genetic legacy in people living today, especially in Melanesia, Papua New Guinea, and Tibet, where Denisovan DNA contributes to adaptations like high-altitude survival. Neanderthals, on the other hand, were better known, with dozens of skeletons across Europe showing their strength, their tools, their rituals. To find them joined in one child meant the prehistoric world was not a set of neatly divided territories, but a tangled landscape of movement, meetings, and mingling. In their 2018 Nature paper, Vivian Sloan and her colleagues emphasized how unexpected this was. Given the limited fossil record, the odds of finding a first-generation hybrid should have been astronomically low. And yet, there she was, nicknamed Denny by the team, as though she were a living person instead of a fragment of bone. Imagine her for a moment, a young girl with no knowledge of the significance her DNA would one day hold, growing up in a world of harsh winters, vast forests, and communities who may have looked different, but were not so different that they could not form bonds. Her life, short though it was, testifies to the fact that humans have never lived in isolation, never been as divided as we sometimes imagine. The lines we draw between species in textbooks were far blurrier in reality, as survival often depended on cooperation, exchange, and sometimes intimacy. The impossible DNA trail hidden in her bones forces us to abandon the tidy boxes of our evolutionary charts. It asks us to picture a past where encounters between Neanderthals and Denisovans were not singular anomalies, but part of a broader pattern of interaction. And if we accept that, then what else must we reconsider? How many other children like Denny once lived and died, unrecorded in the soil, their existence forgotten, until fragments of their bones reawaken thousands of years later to whisper that the boundaries we believe in were never truly there?
Picture a cold evening in Ice Age Europe, tens of thousands of years before modern humans ever set foot on the continent. A small group huddles around a fire, its flickering flames dancing against the rough stone walls of a cave. Their faces are broad and strong, with heavy brows, wide noses adapted to breathe the icy air, and powerful bodies built to endure the brutal winters. These were the Neanderthals, a species of human who thrived across Europe and Western Asia for hundreds of thousands of years. They were not the brutish caricatures often painted in 19th century textbooks. Instead, they were skilled hunters, toolmakers, and even artists in their own right. Archaeological finds across sites like La Chapelle-aux-Saints in France and Shanidar Cave in Iraq reveal a people who buried their dead, who cared for the sick and injured, and who may have painted on cave walls long before Homo sapiens arrived. Chris Stringer, in his book The Origin of Our Species, 2012, notes that Neanderthals were perfectly adapted to their world, evolving distinct traits that gave them an edge in the frozen landscapes of Ice Age Europe. They crafted sophisticated stone tools, known as Mousterian technology, hunted massive animals like mammoths and woolly rhinoceroses, and lived in small bands that were deeply connected to one another. For decades, scientists argued whether Neanderthals were capable of symbolic thought, whether they possessed language, and whether they had the same kind of human spark we claim for ourselves. But the more evidence emerges, the clearer it becomes that Neanderthals were not just primitive cousins. They were another kind of human, different but equal in complexity. And yet, despite their strength and intelligence, they vanished from history roughly 40,000 years ago, leaving only fragments of their bones and whispers of their DNA inside us. The story of the Neanderthals is both one of triumph and tragedy, a reminder of how fragile survival can be even for the most resilient. For over 300,000 years, they endured some of the harshest climates the Earth has ever known, spreading from Spain to Siberia, mastering landscapes where few other creatures could thrive. They were hunters who tracked game with skill and persistence, gatherers who knew the plants of their environments, and survivors who crafted shelters, controlled fire, and clothed themselves in animal skins. Genetic studies, especially those led by Svante Pääbo and outlined in Neanderthal Man 2014, reveal that Neanderthals carried genes associated with language and cognition similar to ours, suggesting they may have spoken, laughed, and told stories just as we do. In caves like El Castillo in Spain, hand stencils and red pigments suggest they may have even created symbolic art. Yet, despite all this, they are gone. One explanation is competition. When Homo sapiens spread into Europe from Africa around 45,000 years ago, they may have outnumbered and outmaneuvered the Neanderthals, bringing new technologies, wider social networks, and more flexible strategies of survival. Another theory points to climate change, which saw rapid swings from glacial cold to milder periods, placing stress on food supplies and habitats. But perhaps the most surprising explanation is that Neanderthals did not entirely vanish. They blended into us. Today, nearly every person of non-African descent carries about 1 to 2% of Neanderthal DNA, a silent inheritance from encounters between our ancestors and theirs. This means that while the Neanderthals disappeared as a distinct population, part of them continues to live in our blood and bones. It forces us to question the very idea of extinction. Can we say a species is gone if it still breathes through us, in our immune systems, our skin, even our thoughts? And if so, perhaps the Neanderthals never truly vanished, but survive as quiet echoes inside every one of us. So what does that mean for the way we define who is us and who is them?
Imagine for a moment that you are standing high on the windswept plateaus of Central Asia, thousands of meters above sea level, where the air is thin and cold, and the snow never truly leaves even in summer. It is here, in these unforgiving landscapes, that traces of an ancient people still linger, not in skeletons laid out for archaeologists to study, not in tools scattered in abundance, but in the very DNA of those who continue to survive in such extreme environments today. These people were the Denisovans, a lineage of archaic humans shrouded in mystery, discovered not by chance encounters with nearly complete fossils, but through the almost invisible signatures hidden inside bone fragments and teeth unearthed in Denisova cave. Unlike the Neanderthals, who left us entire skeletons to reconstruct, the Denisovans have remained elusive. A finger bone here, a tooth there, that was all scientists had. Yet those fragments, when subjected to the revolutionary DNA techniques pioneered by Svante Pääbo and his team, revealed something astonishing: a lineage of humans who were neither Neanderthal nor modern, but something else, a branch of the human family tree that had survived deep into the Ice Age. David Reich, in his book, Who We Are and How We Got Here, 2018, describes how the genetic legacy of Denisovans is still carried by modern populations in Melanesia, Papua New Guinea, and Tibet,
where their DNA contributes to high-altitude adaptations that allow humans to breathe and thrive where oxygen levels are dangerously low. Imagine the revelation, a people who left almost nothing behind. No cave paintings, no elaborate burials, no iconic tools, yet whose bloodline continues to shape how some humans survive today. The Denisovans remind us that history is not written only in artifacts and bones, but also in the code of life itself, silently handed down across millennia. But how do we imagine a people we cannot see? A civilization that left almost no cultural traces, only genetic footprints scattered across distant populations.
The enigma of the Denisovans challenges our very understanding of human prehistory. We know they lived in Asia, stretching perhaps from the cold Siberian mountains to the tropical islands of Southeast Asia, but their range is still uncertain. We know they interbred with both Neanderthals and Homo sapiens, leaving behind genetic contributions that influence our health and biology even today. Immune system genes, altitude adaptations, and more. But we do not know what they looked like. Reconstructions are speculative, drawn from genetic hints and comparisons to Neanderthals, but no complete Denisovan skull has ever been found. Were they as robust as their Neanderthal cousins, with wide chests and strong limbs, or did they carry features that would make them appear more like us? The lack of evidence leaves a haunting silence in the fossil record. What we do know, however, is that they were not a marginal group, but a people who left their imprint across half the globe. In 2019, a study led by Katerina Duca and colleagues in Nature revealed that Denisovan fossils found in the Tibetan Plateau date back more than 160,000 years, proving that they adapted to some of the harshest climates on Earth long before modern humans set foot there. This ability to thrive in extreme conditions suggests a resilience that rivals any of their contemporaries. And yet, despite their strength, they too vanished as a distinct population, absorbed into others or wiped away by time. To know that their blood still flows in certain populations today is both comforting and disquieting. They are gone, but they are also not gone. They exist in the margins of our DNA, a reminder that the human story is not one of pure lines, but of interwoven threads. When we speak of Denisovans, we are really speaking of ourselves, because a part of them quite literally lives in us. So what does it mean for our modern identity if we are, in truth, mosaics stitched together from Neanderthals, Denisovans, and other ancient lineages now lost to the winds of time?
Imagine a young girl walking across the frozen valleys of Siberia 90,000 years ago, the sharp wind tugging at her tangled hair, the snow crunching beneath her feet as she follows the tracks of her kin. She is perhaps no older than 13, not yet fully grown, yet old enough to take part in the tasks that keep her small community alive. Her name is unknown, her face lost to time, but the scientists who uncovered her story have given her a simple nickname, Denny. Unlike other children, however, she carried a legacy written deep in her blood. Her mother was a Neanderthal, her father a Denisovan. She was, in every sense, a child between two worlds. What might her life have been like? Did she live with her mother's Neanderthal band, with their fires flickering in the mouths of caves, their heavy stone tools crafted with practiced hands? Or did she sometimes cross paths with her father's Denisovan kin, who roamed the Siberian landscapes with their own customs and knowledge? The truth is lost, but what remains is a haunting sense of possibility.
Archaeological studies, such as those by Katerina Duca and colleagues in Nature 2019, reveal that both Neanderthals and Denisovans occupied the Denisova cave at overlapping times, suggesting that communities may have shared not only the same landscapes, but perhaps the same shelters, sometimes only separated by decades or centuries. If so, then Denny's existence was not an anomaly, but a reflection of a larger reality, that these groups did not live in total isolation, but sometimes came together in ways both cooperative and intimate. Picture her growing up with stories told around the fire, with the laughter of siblings or cousins, some with Neanderthal traits, others perhaps more Denisovan, all bound by the same struggle to survive in a world of ice and predators. Hers was a world of mammoths and woolly rhinos, of wolves and saber-toothed cats, where survival demanded resilience and unity. And yet, her very being, half one lineage, half another, symbolizes something far greater than survival. It symbolizes the human tendency to connect across divides, to form bonds where none were expected. But what must it have felt like for her? To live at the threshold of two ancient peoples, to embody two worlds in a time when identity was measured not by species names, but by the simple need to endure another winter.
The tragedy, of course, is that Denny's life was short. The fragment of bone recovered from Denisova cave belonged to a girl who died in her early teens. Her story nearly lost to the soil until modern science brought it to light. We will never know the cause of her death, whether it was illness, accident, or simply the harshness of Ice Age life, but her brief existence left behind a testimony more powerful than any long reign could have. Vivian Slonk and colleagues, in their landmark 2018 Nature article, emphasize how astonishing it is that of all the countless remains that could have been found, this one fragment preserved the genetic story of a first-generation hybrid. That fact alone suggests that encounters between Neanderthals and Denisovans were not rare accidents, but recurring events, natural consequences of shared territories and overlapping lives. Denny herself might never have known that she was different. To her, the lines that scientists draw between species would have meant nothing. She was simply part of a family, a community that hunted, gathered, and endured together. Yet from our modern vantage point, she represents something monumental, living proof that human identity has always been complex, always blended, always richer than the categories we try to impose. Imagine standing in that cave where her fragment was found, the silence heavy, the chill of the air unchanged for millennia, and realizing that beneath your feet once walked a child who embodied two entire branches of humanity. Her life, though fleeting, is a reminder that history is not made only by empires or inventions, but by quiet, ordinary people whose existence changes everything we think we know. If a single teenage girl from 90,000 years ago could challenge our deepest assumptions about human evolution, then what other forgotten lives, still hidden in the earth, might yet speak and transform our understanding of what it means to be human?
Close your eyes and picture a frozen forest at the edge of the Altai Mountains where two groups of humans once crossed paths. On one side, Neanderthals, stocky, powerful, carrying stone-tipped spears, their fires warming the dark mouths of caves. On the other, Denisovans, shadowy and elusive, a people known not from their tools or art, but from their genes, drifting across Asia's landscapes. When these groups met, what happened? Were they rivals, competing for the same hunting grounds, eyeing each other with suspicion across the snowy plains? Or did curiosity lead to contact, cautious exchanges of food, tools, or knowledge? At some point, at least for a few, those encounters went beyond survival and turned into intimacy. This was not merely theory, but fact, revealed through the genome of Denny, the hybrid girl. But her case is not unique. Scientists have identified other traces of interbreeding, not only between Neanderthals and Denisovans, but also with early Homo sapiens. David Reich, in his influential book Who We Are and How We Got Here, 2018, explains how genetic studies reveal multiple waves of mixing, small percentages of Neanderthal DNA in modern non-African populations, Denisovan DNA in Melanesians and Tibetans, and even hints of other, more mysterious archaic humans whose identities remain unknown. These encounters, once dismissed as rare, now appear to have been common, shaping who we are today. Imagine the complexity of such relationships, people meeting not as abstract species, but as individuals, perhaps strangers drawn together in fleeting bonds that left permanent imprints in our blood. It forces us to reconsider our picture of prehistory, not as neat, isolated lineages, but as a braided river where streams constantly crossed and merged. If every meeting had the potential to create a new blend of humanity, then how many forgotten children like Denny once lived, their short lives weaving together threads that still run through us today?
The very notion of interbreeding among ancient humans has long been controversial, once dismissed as unlikely or even impossible. For decades, many scholars clung to the idea that species like Neanderthals and Denisovans were separate, distinct, and incompatible with Homo sapiens. But genetic evidence has shattered that view, showing instead that human history is one of mixing, of blurred boundaries. Chris Stringer, a leading paleoanthropologist, emphasized in The Origin of Our Species, 2012, that the more we uncover about human evolution, the less it resembles a straight line, and the more it resembles a tangled web. These unions were not always the result of harmony. Sometimes they may have been coerced, other times violent, but they undeniably happened again and again across continents and millennia. What matters is that the children survived, sometimes thriving, sometimes leaving behind fragments that would later tell their story. Consider the Denisovan DNA that helps Tibetans today live at altitudes where oxygen is scarce. That adaptation was not invented by modern humans, but inherited through ancient interbreeding. Consider the Neanderthal genes that affect our immune systems, our skin, even our susceptibility to certain diseases. These are the echoes of encounters that took place in caves, forests, and river valleys tens of thousands of years ago. Interbreeding was not an exception, but a rule of survival, binding groups together even as they competed. The story of Denny, therefore, is not just about one child, it is a window into a deeper truth, that humanity has always been fluid, its boundaries permeable, its identity formed not by purity, but by exchange. And if this is the case, then what does it say about our modern obsession with divisions, borders, and categories, when the very essence of being human is the blending of worlds that once seemed impossibly separate?
When we look in the mirror, we see ourselves as modern humans, Homo sapiens, the sole survivors of a long and complex evolutionary journey. Yet hidden beneath our skin, deep in the architecture of our DNA, are traces of other humans who walked this earth long before us. Every cell in our body carries a genetic mosaic, fragments of ancient encounters written into the double helix. For people of non-African descent, between 1 and 2% of that code comes directly from Neanderthals, an inheritance from meetings that took place tens of thousands of years ago, as our ancestors migrated out of Africa and into Neanderthal lands. For some populations, particularly in Melanesia, Papua New Guinea, and parts of Southeast Asia, up to 5% of their DNA derives from Denisovans. These numbers may seem small, but their impact is enormous. Studies in recent decades have revealed that Neanderthal DNA contributes to traits ranging from skin pigmentation to the way our immune systems respond to diseases. And Denisovan DNA provides high-altitude adaptations that allow Tibetans to live in oxygen-thin environments where others struggle. David Reich's groundbreaking book, Who We Are and How We Got Here, 2018, details how these genetic legacies shape us even today, not as curiosities of the past, but as living influences that affect our survival, our health, even our personalities. Imagine the intimacy of this realization. When a modern person breathes more easily in the thin air of the Himalayas, it is thanks to a genetic gift from Denisovans who vanished tens of thousands of years ago. When our immune systems fight viruses or bacteria, sometimes it is Neanderthal DNA guiding the response. These are not abstract stories, but real inheritances that shape our lives daily. The more scientists examine our genomes, the more they discover echoes of encounters we once thought forgotten. But if so much of who we are is shaped by those we call other, can we truly claim that Homo sapiens stands alone? Or must we accept that our identity is built upon the very people we once believed had disappeared?
The genetic legacy of Neanderthals and Denisovans is more than just biology. It is a reminder of how connected we are to a deeper past, one that resists neat categories. For centuries, scholars described human history as a ladder, each rung representing progress from primitive ancestors toward the pinnacle of modernity. But DNA tells a different story, one less linear and more interwoven, where branches of the human tree grew apart only to braid together again through encounters, interbreeding, and shared survival. Svante Pääbo, in his Nobel Prize lecture of 2022, emphasized that our genomes are not pure, isolated lineages, but palimpsests, texts rewritten again and again, carrying the faint handwriting of those who came before us. This perspective changes how we think of extinction. Neanderthals may no longer walk the earth. Denisovans may be absent from caves and valleys, but they have not truly vanished. They live on as fragments of code within us, their presence as real as our own reflection. Picture a Tibetan shepherd guiding his yaks across the plateau, his lungs filling with the thin air that would leave most people gasping. That ability is a Denisovan legacy, a whisper from a forgotten people embedded in his blood. Picture someone surviving a pandemic, thanks in part to immune responses shaped by Neanderthal genes. These are not myths or metaphors, but the direct consequences of ancient intimacy. And yet, perhaps the most powerful legacy is not in the percentages or adaptations, but in the reminder that humanity has always been plural, always mixed, always shared. We are not the product of one straight line, but of many threads knotted together, fragile and strong at once. If that is true, then perhaps the divisions we insist on today between races, nations, identities are far less real than we think. And if our very blood proves that we are all mosaics of vanished peoples, then what does it mean to say we are separate at all?
In the end, when we step back and look at the story of Denny, we find ourselves not just learning about a child who lived 90,000 years ago, but about the meaning of humanity itself. Here was a girl who carried within her the blood of two worlds, the robust Neanderthals of Europe and Western Asia, and the mysterious Denisovans of Siberia and beyond. Her life was brief, her body left behind only a single fragment of bone. Yet in that fragment rests a revelation profound enough to reshape how we see ourselves. Denny is not merely an archaeological curiosity. She is a reminder that human history is never simple, never divided into neat categories of us and them.
Instead, it is a web of connections, of crossings, of shared lives and blended identities. Svante Pääbo, reflecting in his Nobel lecture 2022, described how sequencing ancient genomes has shown us that all humans alive today carry within them pieces of other groups once thought lost forever. Denny is the embodiment of that truth, that even in the deep past, humans were not isolated, but part of a living tapestry of interwoven threads. Imagine her as more than a genetic hybrid. Imagine her as a living bridge walking through the Siberian cold, her existence proof that love, curiosity, and connection transcend boundaries. When we study her, we are not just gazing at the past, but at a mirror, for we too are hybrids of countless forgotten unions. And so, as we consider Denny's short but world-changing life, the question lingers: if she, a child of two vanished peoples, could carry within her a message of unity, then what excuse do we have today for clinging to divisions that never truly defined us in the first place?
The legacy of Denny is therefore not only scientific, but profoundly human. She teaches us that our identities have always been fluid, that the story of humanity is not one of purity, but of mixture, not of separation, but of connection. The genes we inherit are not flags of belonging, but threads of continuity, binding us to lives and lineages far beyond our memory. David Reich, in Who We Are and How We Got Here, 2018, reminds us that the genetic blending of Neanderthals, Denisovans, and Homo sapiens is not an exception, but a foundation of who we are. To realize this is to let go of the illusion that we are separate, unique, untouched by others. We are, each of us, walking archives of encounters that took place tens of thousands of years ago. Encounters in caves, forests, mountains, and rivers where different humans met and, in small acts of intimacy, reshaped the destiny of the species. Denny, though she never knew it, carries a message across the abyss of time, that humanity is strongest not in isolation, but in connection. Her story asks us to reflect on our modern world, where borders, differences, and divisions still dominate our thinking. If a child who lived 90 millennia ago could embody the blending of entire species, what does it mean for us to build walls between one another today? If she is a symbol that we are all mosaics of ancient kinships, then perhaps our greatest task is not to emphasize what divides us, but to honor what unites us. And so, as this journey closes, we are left with a final reflection. If Denny, a forgotten girl in a Siberian cave, could survive in our DNA as a reminder of unity, will we choose to learn from her, to see ourselves as one people, stitched together by countless threads of the past?
As we close our eyes and step away from the icy darkness of Denisova Cave, carrying with us the fragile memory of a girl who lived 90,000 years ago, we cannot help but feel the weight of her message reaching across the ages. Denny's story is not just about genetics or fossils. It is about the essence of humanity, about the threads that tie us together across time and space. In her brief life, she carried within her the legacy of two entire peoples, Neanderthal and Denisovan, who once seemed so distant, so separate, yet who came together in a bond that produced her existence. Today, her DNA whispers to us from a fragment of bone, reminding us that we are not the children of one straight lineage, but the woven outcome of countless meetings, unions, and shared struggles for survival. Think about that for a moment. When you breathe, when you love, when you dream, parts of you are echoes of ancestors whose names will never be known, whose faces will never be reconstructed, yet who live on inside you. We often imagine ourselves as isolated, divided by nation, culture, or belief. But in truth, we are all mosaics, tapestries stitched together by forgotten hands. Denny's story is a mirror reflecting the truth that the human journey has always been one of connection, not separation. And so, as we leave her cave and return to our own modern world, the question remains: if a teenage girl who died so long ago can unite entire species within her blood, what excuse do we have today to remain divided by walls of our own making? Perhaps in remembering Denny, we are reminded that our future, like our past, depends on our willingness to come together. If her story moved you, if it made you reflect on what it means to be human, I invite you to join this journey further, subscribe to this channel, and explore the countless other forgotten stories of our shared history. For in listening to the whispers of the past, we may yet discover the wisdom we need for the future.